Okay, on this page we have two integrations to do, but they are a little bit more difficult than the straightforward rules, because as you look at these, hopefully you're spotting that you've got what is effectively a product. You've got an x there and you've got a sine 2x there, and on this one you've got an x and you've got an e term. So this is integration by parts. Okay, so the rule is in the formula book, but I'll write it on my page here before I show you where it is in the formula book. The integral of u times v dash is u times v, take away the integral of v times u dash. Okay, in the formula book, here it is. It writes dv by dx rather than v dash. It writes du by dx rather than u dash, but that is the integration rule that we're going to use. So my two terms, one of them is the u, one of them is the v dash. Generally, you will pick the u as the single x or simpler x term, because that's going to get easier as it differentiates. Okay, it does mean in this case my sine 2x is the v dash, so I have to integrate that before I get going on the rule, which is a bit more annoying because sine integrates to negative cos. The angle stays the same and we divide by the differential for the integration step. So then we can put everything in to the rule. So we have this integration will equal my u times my v. And we're just going to put the minus at the front immediately as I'm writing it, so it doesn't look like an x take away a cos 2x over 2. And then a minus sign from the rule, and then the integral of my u dash times my v. And obviously timesing 1 by something is not going to change it. Okay, I think at this point I'll just deal with the minus minus, because otherwise I will have too many minus signs flying around. So a minus and a minus can make a plus. Doesn't matter that one minus sign is inside the integration. So the first term, the u times the v, whatever it looks like, leave it alone. The second term is the bit you're going to integrate. Now hopefully that is now not a horrible product of two x terms. It's just a trig term we can integrate. So cos integrates to sine, angle stays the same, divide by the differential, which is a 2. We've already got a 2 on the bottom, so we have another 2 that comes to join it, and we end up with a 4 on the denominator. If there were limits, you would put brackets around the whole answer and sub the limits into both of them. Okay, if there are no limits, just put plus c on the end. Okay, so another example, same idea. Let's look at this one. So again, if we pick the u to be the x, the u dash differentiates to be a 1. That means the v dash is the e to the minus 2x. And as we integrate, the e with its power stays the same, but we divide by the differential of the power. Okay, which you can pull that minus to the front if you prefer. Let's write it like that. Minus e to the minus 2x all over 2. Okay, let's put it into the rule. So we want our u times our v. So again, we'll put that minus at the front. Minus signs flying around everywhere. That's the u times the v minus the integral of the u dash times the v. Okay, so it's pretty similar to the first example. It's ease, it's not trig, but apart from that, it's not really different. So hopefully you're feeling fairly comfortable with how this is working. Okay, so I've just tidied up the two minus signs like I did before. And then we're going to go ahead and integrate this, which is no longer a product, it's just an e. So e So the minus 2x stays the same. We divide by the differential, which is a minus 2. We've already got a 2 on the bottom, so that now becomes a minus 4. And again, we can pull that minus to the front. To make it look a little bit tidier. And I suppose you could always take a factor of e to the minus 2x to the out at the front as a common factor to make it look a bit nicer again.